So already we have learned the concept of random variable. Already we have learned concept of the random variable, the concept of the probability density function, the cumulative distribution function, that also Gaussian distributions, and as well we have learned if any distributions follows the Gaussian distributions, it can obey the 68, 95, 99 rule. That things already we have discussed in our previous lectures. Now we in this lecture we will see and how these distributions and where also where these distributions we have to use. So let's see these things. Actually in probability these things are mainly useful in the data analysis, in the questions of the data analysis. In the part of data analysis, this kind of technique we need. So answering the questions about the data. Answering the questions about the data. That's kind of concepts we need to learn. So now let's take an example. Let's take an examples to discuss this thing and to how to where we have used these things. Let's take an example. So first, our examples that I have taken, that suppose let's take I will job a large company. Suppose let's take the first questions is, so example, suppose this is an example. The company that I have jobbed, suppose let's take I have jobbed a large company. Suppose let's take its name is ABC. Suppose let's take ABC company I have jobbed, and in this company, suppose let's take they have 1 lakhs employer, 1 lakh employee that work in this company. Now our job is, our task is on this company, our task is we have to order the t-shirts for all employee. I have to order the t-shirt. I have to order the t-shirts for all employees. That is our tax, and they are in the company, they have the 1 lakhs employees, and to collect the size of the t-shirt for individuals employee, it is a time taking manners, and also it needs some amount of resources and some amounts of money they are have needed. So but that much resources actually I have not. So how we will perform this kind of tasks? So let's see. So and in this company there are various kind of, have various kind of size, they need various kind of, they have a small size, they have medium size, they have large, they have XL. This kind of t-shirts we need, and we don't know any data of our employee. So how we will conclude how much t-shirts we have to make short, how much t-shirts we have to make large? If we make, suppose I make the XL amount of t-shirts in large amount, so it will be not a good one. Actually in our company we don't know any data, how much company it is wear the XL t-shirts, how much company wear the L t-shirts. We don't know actually anything of our employees. So how we will doing these jobs? You don't know, if you don't know anything of our employees. So to doing these jobs, first task that I have to do, first task that I have to do, that I have to do is collect the data for all employees. It means collect the domain knowledge of our all employees. So first I have to collect the data that collect the data for the employees. But collect all the data is a time taking matter. It is not possible. So collect the data for all companies. For all companies, it is not possible because it is a time taking matter and they have needed very large amount of resources. Actually, that's kind of resources I have not. So the collecting of data for all employees is not a good job. So first we have to collect the domain knowledge. We have to avoid this, we have to collect the domain knowledge. We have to collect the domain knowledge for our for these tasks. So actually the domain knowledge is that here the domain knowledge on these tasks, domain knowledge is that, and there are primary knowledge, the height of the people. If suppose this is the simple primary knowledge that I have to take, that if the height of the peoples is greater than, in general, that I have said, this is the common sense. If the height of the peoples is greater than 180 centimeters, in generally they have wear the XL t-shirt. That is the simple domain knowledge. This is primary knowledge. That's the human psychologists are giving this data. If some people's the height of some people's is greater than 190 centimeters, then they in generally wear the XL t-shirts. But there have some exceptionals. So I am not consider the exceptional case here. Just I am taking the general case. And in general, if our height is between 160 centimeter to 180 centimeter, in general, if our height is 160 to 180 centimeter, in generally on this height, the humans are wearing L t-shirt. That we will collect from the human psychologist. This is the simple domain knowledge, expert knowledge, domain knowledge. This is the simple domain knowledge. Okay, that first I have to collect this domain knowledge, because it is impossible to collect the individual data for each individual employee. So first, because of that, we have to collect the domain knowledge. Now because I am collecting the height, if the height of the height is greater than 180 centimeters, then they are mainly wearing the XL t-shirts. If the height of the between 180 to 180 centimeters, then in general they are wear the L seater. Similarly for M, for S, for A, for such kind of these things we have collected. In the second step that we have to do, we have to collect the height of the random sampled data on the whole populations. Means here the population size is 1 lakh. So suppose let's take, we have collect the heights. We have to collect the heights of 500 random employees. We have to collect the 500 such kind of random employees. We have selected the 500 such random employees and we collect its height. And using these heights, we can easily calculate its mean. Its means, and also easily calculated its standard deviation. Okay, so let's take mean is mu and standard deviation is sigma. Let's take. So, and from the expert knowledge, from our expert, we can know that from the expert. So from expert, we know that in this we need the expert. So know that the height is normally distributed. Height of the human is normally distributed. We know these things from our experts, from the experts of that domain. We know, means here the domain is maybe doctor, it may be human psychologist, it may be human experts that study on the human physiology. So that's from these domains, from this kind of experts, we will got this note, we will got this data. So now it is, since the height is the normally distributed, since the height is here normally distributed, so using this mean and the standard deviations, using this mean, since the height follows these normal distributions, and using this mean and the standard deviations, we can easily plot these probability density functions. We can easily plot these probability density functions, and also we can easily find its cumulative distribution function. And easily find its cumulative distribution function. Like that will be. Okay. So if we know here, if our height is greater than 180 centimeters, then that much peoples are wearing XL t-shirts. So here actually this is the CDF, cumulative distribution function. This is the height. This is the height. Suppose let's take it's here is our 180 centimeter. 180 centimeter is here actually. Suppose here is actually our, let's take here is our 180 centimeter. Okay. So now if air is 180 centimeters, then we can easily find this value. Suppose let's take this value is 99, 0.99, and we know its highest value is 1. Its highest value is how much? Its highest value is 1. So we can easily conclude that on these regions, we can conclude that on these regions, we have only 1% of the point. On these regions we have only 1% of the point. Only 1% of the point. So from this we can conclude that the t-shirts that we have need only 1% t-shirts, means here the probability of height greater than equals to 180 centimeters is, we got it is 0.01, means this is simple 1% of the point we have got. So if this from this collected from the sampled data of the random employee, if we got these results from these things, we can conclude that our t-shirts that we need, that XL t-shirts is only 1% on the whole population. So here whole population 1 lakhs. So if it is the 1 lakhs, then we need only its 1% of the 1 lakhs. Means it's only needs here 1% of the 1 lakh. 1% of the 1 lakhs we need only t-shirts, then it will be okay on this, because we got this from distributions from our randomly sampled data. Okay, I think you have understand how these things are workable. Okay, so here the thing that, and I think you have got understand how these things are actually workable. Suppose it will be better I have taken the another examples. Suppose let's take, I have taken it another example 2. Example 2, let's take. So here I am taking the example salaries of the peoples on a company. So suppose let's take, I am working on some company, same company that I have working, it's a large company, and my tax is here, I have interest, my tax is find the salaries of the employees of find the salaries of all employees. Okay, if in this company we have 1 lakhs employee, then to collect it the individual data from all company, it's a time taking, also resource taking matter, so it is not also possible. So similarly here we can doing these jobs. Suppose we know any inform suppose our task is, suppose the questions is here that I have to that the questions is that I have to give the answers. Now the questions is that I have arise here. How many employees? The questions that have arise here. How many employees make a salary that's greater than 100k? Suppose let's take 100k dollar. Suppose how many employee make a salary that's greater than 100k dollar? That's the first questions. Second questions is how many employees make a salary, suppose let's take between the same things that I am doing the job in the t-shirts, 152, suppose let's take 52 50k to, suppose let's take it's 70k. How much? These kind of questions I have arised here for finding the salaries of the employee. How much salaries we will have to give that's greater than $1,000? How much employees that have to give the salaries that's between 50 to $170? Okay, that's kind of questions. Okay, so first we have to get it's the similarly we have to collect from this data, we have to collect its 100 of observations on this data. So we have to collect the, suppose let's take we have collected here from the 1,000 observations from this 1 lakhs peoples. From these 1 lakhs peoples we have collected the thousands observations, and on these thousands of observations, similarly we can count its means, we can easily count its standard deviations, and using the standard deviations we can find its distribution. Suppose from the expert we know that the salary of humans are lying on is follows the normal distributions. From the expert we get that it's the salary of a human it follows the normal distributions, and from the sample data we can calculate its mean and variances. We can easily calculate its mean and the standard deviations, and using this data we can easily calculate. And suppose let's take using these distributions we have find such kind of community distribution function. And this is the sample CDF, this is the sample the salaries. Okay, now first we have to doing the job. How much salary are greater than 1000k? Suppose let's take here is the point, that $100, and suppose let's take this corresponding value is, suppose let's take 0.7. So we can conclude that only 30% only probability of the x probability of the that probability of the x that's greater than 100k dollar is 0.3. We can conclude that this is 30% point. 30% of the whole employee will got the salary that's greater than is equals to $100, 100k dollar. And similarly we can find from here, we can find this we can easily find this thing. So how much points lies between 50 to 70k? Suppose let's take here is the 50, here is the 70, here is the 70. here is the 50, here is the 70k. So suppose let's take this, the point there is 0.4, here is the point that's 70k. Suppose let's take 0.6. How much points we have in these regions? In these regions, in these regions we have, sorry, in these regions we have how much point? In these regions we have 20% of them. So the probability of the random variables 50 to $70, $50 to $70, it's equals to 20%. These things that are useful to make the conclusions. So I think you have understand. I think you have understand the idea how this probability density function, how this cumulative density functions, how this random variable Gaussian distributions are useful all in our real world, in a real world. So the Gaussian distributions that I have used to build the some assumptions, this is simple give us a theoretical model. The Gaussian distributions that I have used, that gives the simple conclusions of some theoretical. This gives a simple theoretical model. This gives a simple theoretical model. Okay, don't know any practically, but theoretically we can assume something, means approximate. We can easily from our data sets we can approx something. We cannot make the thing is properly appropriately, but we can assume we can estimate the some things about our data. This is the first thing that we have to read. And the second thing is that the many natural phenomena observed in many natural phenomena that obeys the Gaussian distributions. So in observation, that is observed that in many natural phenomena, many phenomena many natural phenomena means what? Observed many natural that obeys the Gaussian distributions. Okay, so natural phenomena means height, weight, like salary, that I am discussed, such kind of etc, right? Such kind of things that obeys the Gaussian distribution. This is the main thing. So I think you have to understand the concept, the motto, how the theoretical concept are useful in our real world, not to estimate something about our unknown data. If you have a large amount data, we cannot visualize these things step by step. We cannot plot in the, suppose this kind of thing that's taken the some resources matter, there's taken some time taking matters. So to estimate such kind of things, such kind of situations, though this kind of theoretical concepts are very useful. Okay, I think you have understand the motto of this concept, why these things are useful and why we will learn these things in the world of machine learning.